So after the meet, we'll start from the system.
Okay.
Already I have discussed few things, but since we are starting from the beginning, so we should look at the system again. Okay, so what are the
Okay.
system? It is a system. There will be input and a output. Okay, it is a system. The system has an input as well as an output, and the output would depend based on the system input. Okay, what we are giving at the input, our output will depend. Okay, output depends on both input and system characteristics and what kind of system it is. This thing also depends on the uh, output also depends on this thing. Okay, like like say present xt. If I put the xt, then I'll get the y. Past t minus k. That means we are going to the past. Then the system will also be past t minus y of t minus k, and future t plus k and y t plus k. Okay, so the output depends on the system input and the characteristics of the system. And see, there are various kind of systems like static and dynamic system. So what is the static system? The system whose output depends on the present values of input only is called the static system. See, the system whose output depends on the present value of the input only is called a static system. That means the present value, it depends on the present value. Y of t is equal to 3 of xt. See, so it depends on the present values only. It is memory-less system. It does not contain any memory, any previous memory. Okay. Another one, the system whose output depends on past or future values of input is called the dynamic system. It has a memory. See this. Y of t is equal to 3 of xt. Here, y of t is equal to 3 of x, 3x of t minus 1. That means it depends on the past. This output depends on the past of the input, not the present. Here the present xt, t minus 1, it is the past. Okay, here the output yt depends on the past of the system, that is 3x of t minus 1, and here the output depends on the present situation of the system, which is the 3 of xt. And static system has no memory. On the other hand, the dynamic system has memory. See, so a static system has no memory, dynamic
Okay.
system has memory. Remember this
Um,
thing.
okay, sir.
Okay. Now see, yt is equal to x of 2t. So if I put the value t is equal to 0, then y0 is equal to x0, right? So it is a static. Both are same. Present value of the input is depends on the output. So if I put that t is equal to 1, then it would be x of 2. X of y equals y of 1 is equal to x of 2. It is dynamic because it is a future value, right? Future value. Depends on the future value of the input. And if I put the t is equal to minus 1, x of minus 2. That means it is dynamic. It is the past value. It depends on the past value. It depends on the past value. This is the dynamic. Okay. So past, future, present. Three things. Okay. So static value when t is equal to 0 is equal to when t is equal to 0, then y0 is equal to x0. When t is equal to 1, y1 is equal to x2. Dynamic because it depends on the future. And t is equal to, if I put the t is equal to -1, then the y of -1 is equal to x of -2, which is dynamic because we are depending on the past value. So system is dynamic. Again, another example, y of t is equal to e to the power minus t plus 1 into xt. So it would be a static system because if you put the value 0, 1, 2, 3, any one value, xt would be same, right? If we put the y equal to 0, it would be x of 0. If we put the y equal to 1, t is equal to 1, then it would be x of 1. But the question will arrive, what would happen? Because here in the coefficient t plus 1, it depends on the future value. No, we are not considering the coefficient here. Rather, we are considering only the t is here. Okay. Static system, we check only xt, no need to consider the coefficient. Okay, no need to consider the coefficient. So y of t is equal to x of minus t is equal to dynamic system because obviously if we put the 1, it would be -1. If I put the 2, then it will be -2. So it will depend on the past value. So it is the dynamic system. And if we consider this one, so it is also dynamic system because it will change the value because the range is minus infinity to t, minus infinity to t. So it is not a fixed value. Since it is integration, any value here would go to the yt. Okay, so it is the static system and the dynamic system. So remember, a static system is the memory-less system and depends on the present value, present time, and dynamic system, it depends on the past or
Linear.
future time. Okay, the output depends on the past or future. Okay, so this is the difference between the static and dynamic system. I can ask you in the Viva. Okay, what are the difference between a static system and dynamic system? Okay, and another one, linear and non-linear system. See, the system which follows the principles of superposition is known as the linear system. Okay, so we have already discussed about it, the superposition system. Superposition follows the two laws of additivity and laws of homogeneity. Linear system must satisfy both the laws. So if we consider the linear system, it will satisfy both of the laws. Okay, laws of additivity, laws of homogeneity. What is the additivity? Just add. Okay, see, y1t plus y2t is equal to y prime t follows the laws of additivity. But if it does not follow the y prime t, then it will not be the additivity. It will not follow the additivity. See here, x1t, y1t, x2t gives the output y2t. So summation is y1t plus y2t. Again, if we sum x1t plus x2t, if it goes to the y prime t. So if both these things are same, if both are same, then it is the additivity, it follows the additivity feature. But if these two things are not same, then it does not follow. So it is not the linear system. Okay, x1t, x2t, y1t, y2t, y1t plus y2t, x1t plus x2t, y prime t. Okay, so laws of homogeneity. So what does it mean? xt is equal to system. If I put the input as a xt, and then I will get the output yt, and if I multiply it by k, then it would be kyt. And if I put k here before the system, kxt y prime t. So if those two are same, then it follows the law. If those two are not same, then they do not follow the, they does not follow the, it does not follow the law. So it is the linear system. Okay, so see, linear and non-linear system. So linear system should follow these two, but the non-linear system would not follow these two. Okay. So here is an example is given. See, y of t is equal to x of sine t. So y of 1t, x1 sin t, y2 t, x2 sin t. So if I add these two, then we'll get the same. Again, if I multiply it by kyt into kx and t, see, so those, it is also same. In that case, the system is linear because it does follow all the superposition laws. Okay, both laws. If it follow the both laws, then it is the linear system. Okay, another one. Yt is equal to x of t square. Okay, it will also be a linear system. Okay, if you add, then you'll see it will also be a linear system. Okay, it will also be linear system from 1 and 2. Okay, so it is a linear system. Again, y is equal to x square t. So it will not be linear system because here the system will change. Okay, so it is a non-linear system. Now again, another thing, causal and non-causal system. Oh, you just check these things. Yt of sin t is equal to xt. Okay, yt is equal to e cube xt. Yt is 2t plus xt. Okay, check this thing. Check this thing at your home. Now see, another one, causal and non-causal system. So what is the causal system? Is a system whose output is independent of future values of input. Depends on either present or past or both value. So causal system what? Causal system is a system whose output is independent of future values of input. So independent of future values of input. It is the causal system. Non-causal system is a system whose output depends on future values of input at any instant. Causal system is a system whose output is independent of future values of input, depends on either present or past or both value input. Non-causal system is a system whose output depends on future values of input at any instant. So what is a non-causal system? In the system whose output depends on what? Depends on the future values of input at any instant. So it depends on the future values. Okay, so non-causal system depends on the future values of any system. Here, so causal and non-causal difference. See yt. See independent. Independent means it doesn't depend. Okay, and it is depend. So causal system, it does not depend on the output of the future value. Output does not depend on the future value of the input. On the other hand, in the non-causal system, output depends on the future value of the input system. Now see, so yt is equal to x of t plus t. So it depends on the future values, right? T plus 2. So it is what? It depends on the future output, depends on the future values. So it is a non-causal system. This is a non-causal system, right? Those are the non-causal system because all of those things are depends on the future value. Okay. See, y of 0 is equal to x of 2. Definitely depends on the future value of the input. Y of minus 1 is equal to x of 1. So it depends on the future value. Y of 1 is equal to x of 2. Y of t is equal to x of t plus 2. So we can call it non-causal or anti-causal. Anti-causal system output depends on the future input. Anti-causal system is what? Output depends on the future input. Anti-causal system is always non-causal system. Another one, yt is equal to 3t. See, if I put the t is equal to 0, then those would be 0. Y is equal to 1, is 3, future input. So the non-causal system, it would be non-causal system. Again, y of t is equal to, say, x of 3t, where t is less than 0, and y of t is equal to x of t minus 1, t is greater than or equal to 0. So minus 1, y is equal to minus, t is equal to minus 1. Since it is less than 0, minus 3, first input, y is equal to 1. So if I put the t is equal to 0, t is equal to 0, it would be it would be y1. Okay. So we have checked two things. First value is equal to t, t is equal to 0, then it will be minus 1. If I put the minus 1, y is to minus 1, then it will be like this, x equal to 0. Okay, so t is equal to 1, so it would be 0. So it depends on the past value. So this is a causal system. So it does not depend on the future value, it depends on the past value. So you can say this is a causal system. This is a causal system. Again, another thing. So say coefficient, the coefficient does not depend here. We will look at the main thing here. Term of x, we will look at the term of x. We will not look at the coefficient. We'll look at the x term. Okay, we'll look at the x term. We'll not look at the coefficient here. And time variant and time invariant system. Here comes another one, time variant and time invariant system. So time variant and time invariant system, xt system, it yt and delay, if we delay t of t minus t naught, delay if we put the delay before, so if those things are same, then it is time invariant system, and if it does not maintain the rule, then it will be time variant system. That means time invariant means it depends on the time, and time variant means it does not, it time invariant means it does not depend on the time, wherein time variant means it does depend on the time. Okay, that is the difference here. See, now again yt, another example. See, yt is equal to x of 2t. So x of 2t, if I put that delay 2t minus t naught, if both are same, no, both are not same. So see, y of t minus t naught, 2t, x of 2t. So instead of t, it would be 2t, 2t minus t naught, and the y prime t, x of 2 into t minus t naught multiplied. So these are not same, these two are not same. So this is the time variant system. So it is a time variant system. So if it is same, then it is the time invariant. If it is same, then it will be called as the time variant system, time invariant system. And another thing is stable and unstable system. The system whose output is bounded for bounded input at every instant of time, it is called the stable system. A system whose output is not bounded for a bounded input is called the unstable system. So some unstable and stable system. These are stable and unstable system. Bounded input and output. The signal which is finite from minus infinity to infinity time. Bounded signal example. This is the example bounded signal. Uh, See here is example. Y of t is equal to t of xt. We take bounded input. Let's say xt is equal to ut. Xt into ut is step response. So yt of t into ut. So is equal to rt. Rt is unbounded. So unstable system. Like this, some other examples are also given here. And invertible and non-vertible system. Invertible and non-vertible system. Invertible and non-vertible systems are also there. Okay. See, the system which has one-to-one mapping between input and output at every instant of time is called the invertible system. The system which has many-to-one mapping between input and output is called a non-inverting system. So one-to-one is the inverting, many-to-one it is called the non-invertible. Invertible and non-invertible. Invertible means one-to-one, non-invertible means one-to-many. Okay, depends on the one-to-many. See here. 2. 2 has A and B, A and C. Okay. Some examples they have given here, like 1 to 1, non-invertible. 1 to 1, non-invertible. 1 to many, non-invertible. Non-invertible and invertible. Yeah. Okay. And linear time invariant system, LTA, this is important. LTA system, linear time invariant system. Both linear and the time invariant. Delta T impulse signal, HT impulse response. For LTA system, the output is called impulse response when the input is impulse signal, delta T. Impulse response is to show the characteristics of LTA system only. Impulse response is in time domain. Okay, these are the feature. Okay, again, the system can be defined by transfer function. Transfer function is in frequency domain. Transfer function is used to when. So, do you know what is the transfer function? Transfer function is this is the transfer function actually. Okay. Transfer function is the ratio of the output and the input of a system in frequency domain. So if you skip the frequency domain, your definition would not be valid. Okay, so transfer function is the ratio of output and input of a system in frequency domain. Transfer function is the ratio of output and input of a system in frequency domain. And input of a system in the frequency domain. That is the transfer function. Okay, output by input. Fourier. So Fourier, if we go to the Fourier, then it would be H omega. If we go to the Laplace, then it would be Hs. Okay, and convolution, another term, convolution term. When Ht of a linear time invariant system is known and the input is given, then we can find the output by is a mathematical Tolon's convolution. Okay, so in the final, actually we'll learn about the LTI system, convolution system, those system. Okay, we'll learn about those system in the final, from the very next class. Okay, we'll start from the linear time invariant system. Okay, so we'll start from the linear time invariant system from the next class, inshallah. Okay.